my entire career is going after problems that are just so hard, bordering delusional. To me, AGI will not be complete without spatial intelligence, and I want to solve that problem.
It has over 80,000 citations, and it really kicked off one of the legs or stools for AI, which is the data problem. Tell us about how that project came about. It was pretty pioneering work back then.
Yeah, well, first of all, Diana and Gary and everybody, thanks for inviting me here. I'm so excited to be here because I feel like I'm just one of you. I'm also an entrepreneur right now. I just started a small company, so very excited to be here. ImageNet was, yeah, you're right. We actually conceived that almost 18 years ago. Time really flies. I was a first-year assistant professor at Princeton. Oh, wow. Hi. Hi, tigers. But there is still a group of us, starting from the founding fathers of AI, right? John McCarthy, and then we go through people like Jeff Hinton. I think we just had an AI dream. We really, really want to make machines to think and to work. And with that dream, my own personal dream was to make machines see, because seeing is such a cornerstone of intelligence. Visual intelligence is not just perceiving, it's really understanding the world and do things in the world. So I was obsessed with the problem of making machines see. And as I was obsessively developing machine learning algorithms, at that time we did try neural network, but it didn't work. We pivoted to BaseNet to support vector machines, whatever it was. But one problem always haunted me, and it was the problem of generalization. If you're working in machine learning, you have to respect that generalization is the core mathematical foundation or goal of machine learning. And in order to generalize, these algorithms needs data. Yet no one had data at that time in computer vision. And I was the first generation of grad student who was starting to dabble into data because I was the first generation of graduate student who saw the internet, the big internet of things. So fast forward, 2000, around 2007-ish, my student and I decided that we have to take a bold bet. We have to bet that there needs to be a paradigm shift in machine learning, and that paradigm shift has to be led by data-driven methods. Things in the world. So I was obsessed with the problem of making machines see. And as I was obsessively developing machine learning algorithms, at that time we did try neural network, but it didn't work. We pivoted to BaseNet to support vector machines, whatever it was. But one problem always haunted me, and it was the problem of generalization. If you're working in machine learning, you have to respect that generalization is the core mathematical foundation or goal of machine learning. And in order to generalize, these algorithms needs data. Yet no one had data at that time in computer vision. And I was the first generation of grad student who was starting to dabble into data because I was the first generation of graduate student who saw the internet, the big internet of things. So fast forward, around 2007-ish, my student and I decided that we have to take a bold bet. We have to bet that there needs to be a paradigm shift in machine learning, and that paradigm shift has to be led by data-driven methods. And there was no data, so we're like, okay, let's go to the internet, download 1 billion images, that's the highest number we can get on the internet, and then just create the entire world's visual taxonomy. And we use that to train and benchmark machine learning algorithm. And that was why ImageNet was conceived and came to life.
And it took a while until there were algorithms that were promising. It wasn't until 2012 when ImageNet came out, and that was the second part of the equation with getting to AI, was getting the compute and throwing enough at it and algorithms. Tell us about what was that moment where you started to see, oh, you seeded it with data, and now people started, the community started to figure more things out for AI.
Right. So between 2009, we published this tiny little CVPR poster. In 2009 to 2012, the Alex that there were 3 years that we really believe that data will drive AI, but we had very little signal in terms of if that was working. So we did a couple of things. One is we open source. We believed from the get-go we have to open source this to the entire research community for everybody to work on this. The other thing we did is we created a challenge because we want the whole world's smartest students and researchers to work on this problem. So that was what we call the ImageNet challenge. So every year we release uh, a testing data set. Well, the whole ImageNet is there for training, but we release testing and then we invite everybody openly to participate. And then the first couple of years was really setting the baseline. The performance was in a 30% error rate. It wasn't zero, or I mean, it wasn't completely random, but it wasn't that great. But the third year, 2012, I wrote this in a book that I published, but I still remember um, it was around the end of summer that we were taking all the results of ImageNet challenge and running it on our servers. And I remember it was late night. One day I got a ping from my graduate student. I was home, and said, we got a result that really, really stand out and you should take a look. And we looked into it. It was convolutional neural network. Something, it wasn't called Alex that at that time. That team, that Jeff Hinton's team, was called Supervision. It was a very clever play of the word super as well as supervised learning. So supervision. And we look at what supervision did. It was an old algorithm. Convolutional neural network was published in the 1980s. There was a couple of tweaks in terms of the algorithm, but it was pretty surprising at the beginning for us to see that there was such a step change. And of course, uh, we, I mean, the rest of the history you all know. We presented this in the ImageNet Challenge workshop in that year's ICCV Florence, Italy, and Alex Kruszewski came, and many people came. I remember Jan LeCoug also came, and now the world knows this moment as the ImageNet Challenge Alex that moment. I do want to say that the it's not just convolutional neural network. It was also the first time that two GPUs were put together by Alex and his team, and were used for the computing of deep learning. So it was really the first moment of data, GPUs, and neural network coming together.
Now, following this trend of the arc of intelligence for computer vision, ImageNet was really the seed to solve the concept of object recognition. Then, right after that, it started to also, AI got to the point that could solve scenes, right? Because you had a lot of the work with your students like Andrew Kaparthi being able to describe scenes. Tell us about that transition from objects to scenes.
Yeah, so ImageNet was solving the problem of you're presented with an image and then you call out objects. There's a cat, there's a chair, and all that. That's a fundamental problem in visual recognition. But ever since I was a graduate student entering the field of AI, I had a dream. I thought it was a 100-year dream, which is storytelling of the world. Is that when humans open their eyes, imagine you just open your eye in this room. You don't just see person, 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 chair, chair, chair. You actually see a conference room, with screen, with stage, with people, with the crowd, the cameras. You actually can describe the entire scene. And that's a human ability that is at the foundation of visual intelligence. And it's so critical for us to use in terms of our everyday life. So I really thought that problem would take my entire life. I I literally, when I graduated as a graduate student, I told myself on my deathbed, if I can create an algorithm that can tell the story of a scene, I've succeeded. That was how I thought my career would be. Imagine, Alex, that moment came, deep learning took off, and then when Andre and then later Justin Johnson enter my lab, we start to see signals of natural language, and vision start to collide. And then Andres and I proposed this problem of captioning images or storytelling. And long story short, around 2015, Andres, Andre and I published a series of papers that was among the first, with a couple of concurrent papers of making literally a computer that captioned an image. It was, I almost felt like, what am I going to do with my life? That was my lifelong goal. It was such an incredible moment for both of us. Um, and last year I gave a TED talk, and I actually used a something that Andre tweeted a couple of years ago. Around the time he finished image captioning work, that was pretty much his dissertation. I actually joked with him. I said, "Hey, Andre, why don't we do the reverse? Take a sentence and generate an image." And of course, he knew I was joking, and he said, "Ha ha, I'm out of here." The world was just not ready.